Hello, my mathematical friends. So today is the last lesson of measurement with composite objects. Now, really, composite objects isn't anything new that we have to talk about. Rather, it's putting a bunch of pieces together, okay? So here I have a calculator, and let's call this calculator a, what would it be? Well, it would be a rectangular prism, right? I have a rectangular base, two rectangular bases connected by rectangles. So that would be a rectangular prism. Now, let's call this whiteboard marker, let's call that a cylinder, okay? Just humor me for a second. You know how to get the volume and surface area of a rectangular prism. You know how to get the volume and surface area of a cylinder, okay? If I did this, that, oh, now you can see that I'm not good at balancing things, but that would be a composite objects. Now, the nice thing about trying to find the volume, so you caught what it was. Now, I'm going to draw it for you because otherwise you'll just sit there and laugh at me the whole video while I try and, okay, so this is what I just did. Okay, so the nice thing about a composite object is the volume, you just find the volume of this guy and you find the volume of this guy, okay? And then you just add them together. So volume of composite objects really isn't all that complicated. You just have to find the volume of the separate ones and add them together. It's the surface area that's a little bit more complicated because you have to think about the fact that, you know, if this is one 3D object, my hand, and this is the other 3D object, okay, and I put those 3D objects together, I'm now hiding surfaces, okay? And what you have to understand is there's two surfaces I'm hiding. I'm hiding both palms of my hands there, right? So there are two surfaces that have now disappeared, and you have to account for that, okay? Now, some kids like to just find the surface area of one object, find the surface area of the other object, add them together, and then subtract the things they don't see. Some kids just like to kind of build a new formula based on what they need, okay? So for instance, with this guy, what I would say is, well, what do I not see? I don't see this circle anymore, and I don't see that circle twice. I don't see the bottom of the cylinder, and I don't see the circular shape that's covered on the top of this rectangular prism, okay? That's okay. We can just find the surface area of the rectangular prism then, and find the surface area of the wraparound only. Because if I found the surface area of the wraparound only, I'm ignoring the top circle and the bottom circle, which is essentially the two circles that get hidden there, okay? So I'm accounting for that top circle because I didn't subtract anything from the surface area of the rectangular prism. That's where that top circle is, okay? So it's like I took this top circle and I moved it here so that I could get that total surface, and then what's left would just be that wraparound, okay? It can be a very hard and frustrating thing to visualize, so take your time with this, okay? Really work on developing the formula you're using, really make sure you're understanding what you can and can't see, and communicate all those things to me, okay? I never wanna give you a composite object shape and have you just give me an answer. Okay, it's all about your thought process behind where that answer came from. So be super careful of that, okay? All right, so a composite object simply means a combination of two or more geometric objects from a form a composite object or shape. To solve composite object questions, we must have a strong understanding of the components of each equation in order to modify the equations accurately. Okay, so consider the following: the lateral area of a silo. So remember that a silo, remember that the lateral area is the first thing I wanted to talk about there. The lateral area means you're not including the base, okay? And then a silo is a cylinder with an inverted cone on the top, okay? So the lateral area, well, what do you see? You see, let me just open up my highlighter here. You see this wraparound for sure, okay? And you see this wraparound. You do not see any of those circles because you're not including the base. And then on the top, both circles get hidden because the inverted cone and the cylinder are touching each other, okay? So if I was to try to develop a formula for that, I would say, okay, the volume of the cylinder is 2 pi r squared plus 2 pi r h, and the volume of the cone is pi r squared plus pi r h. But really, all I need is the wraparound. So I just need this right now for the lateral area of this shape. And so I end up with 2 pi r h plus pi r s. Okay, now this question didn't ask you to figure it out. It just asked you what would the formula be. We're just talking for a minute about this concept of developing a formula. Okay. Okay, what if I asked you for the volume of this ice cream cone? Okay, so that would be a hemisphere and a cone together. And again, remember I said earlier, the volume is actually pretty easy because you take the volume of the cone, you take the volume of the hemisphere, and you just add them together. There's nothing you have to think about with the unseen surfaces. That doesn't affect the volume, okay? So I know that the volume of the cone is 1/3 pi r squared height, and I know that the volume of the hemisphere would be 2/3 pi r cubed, so I just add them together, okay? All right, so now let's actually try and do a question. Determine the surface area and volume of the composite object below. Round your answer to the nearest whole number. Now I've made surface area a different color there just because that's the one I'm going to start with. We're going to take a look at the surface area. So again, I've got a cylinder. I know the formula for surface area there. And I've got a hemisphere. I know the formula for the surface area there. But what do I not see? Well, I don't see these two circles, okay? It did not tell me that I couldn't include the bottom. So for this one, I will include the bottom, okay? We will make it very obvious if I don't want you to include the bottom. So like if I say find the surface area of a tool shed, for instance, well, you're not gonna go paint the bottom of a tool shed, okay? Okay, so for this guy, I've developed my formula to say, I've got pi r squared, which would be this bottom circle, and then I've got this wraparound, that's the 2 pi r h, and then I've got the hemisphere. Now, some of you may say, oh, Hill, you're wrong. The hemisphere is 3 pi r squared. You're right, but remember that that flat surface that I create with the hemisphere, I actually don't see right now because it's sitting on the top of the cylinder. So I actually only do see the 2 pi r squared that's on the outside of that hemisphere, okay? Now, I see two terms that both involve pi r squared, so I can simplify that up a little bit, and I'll say that that's 3 pi r squared plus 2 pi r h. I know r is 2, and I know that h is 4, so I plug those numbers in, and then I just use my calculator. Remember to use the pi button, and remember to follow the proper rounding instructions. This one said round to the nearest whole number, so I have done that, 88 feet squared. Okay, surface area is 88 feet squared. All right, now you are asked for the volume. Okay, so volume is much easier. I just find the volume of the cylinder and I find the volume of the hemisphere and I just add them together, okay? So volume of the cylinder was pi r squared h. Volume of the hemisphere is 2 over 3 pi r cubed. I know r is 2 and h is 4. Plug that all in, throw it in my handy dandy trusty dusty calculator. And again, it was to the nearest whole number, so my answer is 67 feet cubed. Okay, don't forget that cube on your units there. Okay. Oh, look, a tool shed. We were just talking about a tool shed. A tool shed is formed by a rectangular prism with a triangular prism as its roof. Determine the surface area and the volume of the tool shed. Round to the nearest whole number. So I'm going to deal with the surface area first. In order to deal with the surface area, there is one piece here that I'm missing, and it is that piece right there. I need to know that length. Think back to where we talked about that Toblerone bar box a couple lessons ago. I need to know that length because that forms the dimensions of this piece of the roof. This piece of the roof here is a rectangle, and so I need to know this guy. Now, what's going to happen is I know the height of this triangle is 3, and I know that it cuts this base, which is 4, because it would be the same as that, right? I know it cuts the base into half, so I know that this piece here is 2 and this piece here is 3. So I'm going to use the Pythagorean Theorem to figure out my missing piece. So x squared is 2 squared plus 3 squared. X squared is 13. So I know this missing piece can be called root 13. Again, I'm going to leave it as root 13 because I don't want to run into a rounding error, okay? All right, so for the surface area, what do I have? Well, I've got 2 of these rectangles. I'm actually just going to put on a highlighter, and we're going to walk ourselves through this for a sec. Sorry, just 1 sec. Okay, so I've got 2 of these rectangles, okay, which is 4 by 5. So I'll have 4 by 5 by 2. I have 2 of these rectangles, which are 5 by 6. So I'll have 5 by 6 by 2. I have 2 of these rectangles, which would be the root 13 by 6. So I have root 13 by 6 by 2. Okay, and I have 2 of these triangles. The area of a triangle is base times height divided by 2. So that would be 2 of 4 by 3 divided by 2. Okay, and so I stick all that together in a formula like so. Okay, so I had 2 6 by 5s, 2 4 by 5s, 2 4 by 3 divided by 2s, and 2 root 13 by 6s. Okay, plug all that into my calculator. Make sure you're doing this right. Make sure you can plug this in properly. You need to get the same answer as me. And you should be getting 155 feet squared. 155 feet squared. Okay, then for the volume, I just have to find the volume of each prism and add them together. So the volume of the bottom guy would be 4 by 6 by 5. Remember, it's the base area times the height. So the base area is 4 by 6 times the height. And then the volume of my triangular prism, the base is the triangle. So I find the area of the triangle, 4 by 3 divided by 2, and multiply it by the height. Remember, the height is such, assuming that the base is actually on the bottom. So this guy here would be the height, because I'd have to take that triangle and flip it so that the base is actually on the bottom. Okay, all right, so plug all that into your calculator and you should get 156 feet cubed. Okay, 156 feet cubed. Awesome. Okay, so that's it. Give yourself, like I said, give yourself lots of time to practice this and really try and ask yourself, especially with the surface area. Okay, surface area is a little more complicated than the volume. Ask yourself, am I taking into account what I can see and what I can't see? Okay, as always, if you have any questions, please, please, please connect with me. That's what I'm here for. Okay, all right, we'll talk to you soon.